According to the National Electrical Code, Section 314.20 states that junction boxes shall be accessible. Section 314.28 states that boxes used for extension shall be of sufficient size to provide space for all conductors and their connections. Section 314.16 ATWA states that boxes, except switch and outlet boxes having no knockouts, shall be secured to a stud, joist, or rafter with screws or utility straps, or to hollow concrete blocks with approved masonry nails. It is not allowable to make an extension ring from a pull box and mount it over an existing flush-mounted box. Extension rings are not specifically allowed by the National Electrical Code, and they do not meet the requirement for boxes to be accessible. Additionally, using a pull box would not provide sufficient space for all conductors and their connections, and it would not be securely fastened to the concrete. Instead, the preferred method for extending an existing flush-mounted box is to install a larger flush-mounted box over the existing one, ensuring proper alignment and securing. You could also use a box extender that is designed for the specific size of the existing box. In the case of a 10-inch by 10-inch box, an 8-inch by 8-inch by 2 and 1/8-inch extender would be suitable. When dealing with electrical boxes and their extensions, compliance with the National Electrical Code is crucial for ensuring safety and proper functionality. The National Electrical Code, or NEC, sets the standard for electrical wiring and equipment installation in the United States. It aims to protect people and property from hazards that can arise from the use of electricity. Several sections of the NEC are particularly relevant when considering the extension of electrical boxes. Firstly, Section 314.20, which mandates that junction boxes be accessible, is a key requirement. Accessibility ensures that the electrical connections within a box can be inspected, maintained, and repaired without undue difficulty. Covering a junction box with a method that permanently encloses it violates this principle because it obstructs access to the wiring inside. Secondly, Section 314.28 stipulates that boxes used for extensions must be of sufficient size to accommodate all conductors and their connections without overcrowding. Overcrowding can lead to insulation damage, short circuits, and overheating, all of which pose significant safety risks. The proper sizing of the box is essential for maintaining adequate space for heat dissipation and preventing mechanical stress on the conductors and connections. Thirdly, Section 314.16 ATWA addresses the secure fastening of boxes. It states that boxes, except for certain types, must be securely attached to a structural element such as a stud, joist, or rafter, using appropriate hardware like screws or utility straps. This requirement ensures that the box remains firmly in place, protecting the wiring and preventing it from becoming dislodged or damaged. Modifying a pull box to create an extension ring and mounting it over an existing flush-mounted box is generally not permitted under the NEC for several reasons. Firstly, it typically fails to provide adequate accessibility. Cutting into the back of a pull box and attaching it over an existing box may create a situation where accessing the interior wiring becomes difficult or impossible without dismantling the entire assembly. Secondly, using a pull box in this manner may not provide sufficient space for all the conductors and connections, especially if the existing box is already filled to capacity. Thirdly, it is unlikely that such a modification would result in a secure and stable installation that meets the requirements of Section 314.16 ATWA. Instead of attempting to create a makeshift extension, it is recommended to use approved methods that comply with the NEC. One common approach is to install a larger flush-mounted box over the existing one. This involves carefully aligning the new box with the old one and securely fastening it to the surrounding structure. It is important to ensure that the new box is properly sized to accommodate the existing wiring and any additional conductors that may be needed. Another option is to use a box extender specifically designed for this purpose. Box extenders are available in various sizes and configurations to fit different types of electrical boxes. They provide a convenient way to increase the depth of the box without having to replace the entire unit. When selecting a box extender, it is important to choose one that is compatible with the existing box and that provides sufficient space for the wiring. In the specific scenario of extending a 10-inch by 10-inch box, an 8-inch by 8-inch by 2 and 1/8-inch extender may be a suitable option, depending on the specific circumstances and the amount of additional space required. However, it is always advisable to consult with a qualified electrician to determine the best approach for your particular situation. In addition to the above considerations, it is also important to be aware of any local codes or regulations that may apply to electrical installations in your area. Local codes may have additional requirements or restrictions that go beyond the NEC. It is always a good idea to check with your local building department or electrical inspector to ensure that your installation complies with all applicable codes. The importance of using the correct tools and materials cannot be overstated. Using substandard or inappropriate tools and materials can compromise the safety and reliability of the electrical installation. For example, using the wrong type of screws to fasten a box can result in a loose connection that could eventually lead to a fire. Similarly, using undersized conductors can cause overheating and potentially damage the wiring. It is always best to use high-quality tools and materials that are specifically designed for electrical work. When working with electricity, safety should always be your top priority. Electricity can be dangerous, and even a small mistake can have serious consequences. Before starting any electrical work, it is important to disconnect the power to the circuit you will be working on. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It is also a good idea to use a voltage tester to verify that the power is off before touching any wires or terminals. In addition to disconnecting the power, it is also important to wear appropriate personal protective equipment such as safety glasses and rubber gloves. Safety glasses will protect your eyes from flying debris, and rubber gloves will protect you from electric shock. It is also a good idea to work in a well-lit area to avoid making mistakes. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Electricity is not something to be taken lightly, and it is always better to be safe than sorry. The National Electrical Code is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date in the latest edition of the NEC to ensure that your electrical installations comply with the most current requirements. The NEC is available for purchase from various sources, including the National Fire Protection Association, or NFPA, and online retailers. You can also often find the NEC at your local library. Studying the NEC is a valuable way to increase your knowledge of electrical safety and best practices. The NEC contains detailed information on a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. By familiarizing yourself with the NEC, you can make more informed decisions about your electrical installations and help to ensure the safety of yourself and others. In addition to the NEC, there are many other resources available to help you learn more about electrical safety and best practices. These resources include books, articles, websites, and training courses. Many vocational schools and community colleges offer courses in electrical wiring and safety. These courses can provide you with hands-on training and the knowledge you need to work safely with electricity. There are also many online resources that offer information on electrical safety and best practices. However, it is important to be careful when using online resources, as not all of them are accurate or reliable. Be sure to check the credentials of the source before relying on any information you find online. Working with electricity can be a rewarding and challenging experience. However, it is important to remember that electricity can be dangerous, and it is always best to err on the side of caution. By following the guidelines in the NEC, using the correct tools and materials, and taking appropriate safety precautions, you can help to ensure the safety of yourself and others. Remember, accessibility is key. Conductor fill is critical. Secure attachment is essential. Always consult the NEC. Prioritize safety above all else. Stay informed about code updates. Seek professional help when needed. Never compromise on quality. Pay attention to detail. Electricity demands respect.